Hello student, how are you all? I hope you all are doing good. I'm Pooja Tripathi, your teacher. So student, have you ever heard the term similarity or the proportion? How can we say that these things are in proportion or these things are similar? So there are certain criteria. Based on these criteria, we can say that these things are proportion or these things are similar. So all these things we are going to understand in this chapter. So the chapter is Proportional Reasoning 1. Our learning objectives are understanding the idea of similarity, the principle of proportion, understanding ratios, solving for an unknown in the proportion, real life uses of proportional reasoning, proportional division and unit conversion. We are going to start with understanding the idea of similarity. In everyday situation, we often compare things around us. We notice that one tree is taller than another, or one scooter travels faster than another. These comparisons usually deal with the size and quantity. But what happens when we want to describe the shape of an object rather than just how big it is? For example, why does a photo shrink neatly when resized on the phone, but look stretched or squished when resized incorrectly? So, the explanation lies in the mathematical concept of similarity, which is closely connected to ratio and proportionality. What makes two pictures similar? Imagine you have an old photograph of your grandfather or grandmother. The original print may be large, but when including it in the school notebook, the original print may be large, but when including it in the school notebook, we often reduce its size, like passport size. Suppose that of the notebook version, 1 centimeter of the picture represents 5 centimeter of the actual photograph. So like this, you can see the difference. A, B, C, different sizes. Now D and E. Now to understand the similarity, let us consider several reduced and enlarged copies of your grandfather's picture or grandmother's picture. Some pictures look perfectly natural, while others appear widened, elongated or compressed. So you can see the difference. Some pictures are like perfect, some are like very much stretched or elongated, or some are very compressed. Why does this happen? The answer becomes unclear when we compare the width and height. Activity measurement of the compare. Use a ruler to measure each picture carefully. Record the width and height in the table or below. So you have to record the height and width of each picture and write here. Now understanding proportional changes. A photograph retains in the natural look only when both its width and height are changed by the same multiplier, means same proportion, also called the scale factor. When the two dimensions are scaled differently, the image becomes distorted. Let us study the picture that appear correct, comparing the picture C, that is 3 centimeter into 4 by 5 centimeter, with the picture A, that is 6 centimeter and 9 centimeter. New width 3 centimeter, that is the half of 6 centimeter, and new height, that is 4.5, that is exactly half of 9 centimeter. So both dimensions are reduced by the same factor, the scale factor, that is half. Both are reduced by half. Comparing picture D, that is 12 into 18 centimeter, and the picture A, that is 6 into 9, that is also, here you can see the new width, that is double of 6, and new height, that is double of 9. So both measurements are enlarged by the factor, the scale factor is 2. Since both width and height are altered by the same ratio of the picture C and D, they look similar to the picture A. Why other picture look distorted? Now take the picture B. Suppose the picture B has the width of 6 centimeter, same as the original, but the height is changed to 12 centimeter. Width of the scale factor is 1 and height of scale factor is 2. Because the two factors are not equal, the picture appears stretched vertically. Now we will take the picture E. If the original rectangle is changed into the square 7 into 7, width of scale factor is different from the height scale factor. Thus the picture is no longer maintain its original shape. So both the factor, all the factors should be changed in the same ratio or same scale. Important rule for similarity. A picture remains similar to the original only when its width and height are changed in the same ratio. This equal ratio keeps the photo shape intact whenever both dimensions grow or shrink proportionately. Means both are changing in proportion, the shape remains similar even though the size differ. The principle maintained proportion is the foundation of ratio, scaling and similarity in geometry. Now understanding ratio. In the previous activity with resized photograph, we learned that the shape of an image stays intact only when the relationship between its width and height remain unchanged. In mathematics, such relationships are expressed using very important idea that is called ratio. Now what is a ratio? A ratio is compare two quantities of the same type. In ratio we compare two quantities that should be of same type. It is written as A ratio B and read as A to B. Here A and B are called the terms of the ratio. This notation simply means for every A unit for the first quantity, there are B unit of the second quantity. Now writing ratio as fractions. A ratio can also be expressed as a fraction which often easier to work with. A ratio B is equivalent to A upon B. The first term becomes the numerator and the second term becomes the denominator. Now we will take an example here. Suppose the picture P has the width of 5 cm and height of 8 cm. The ratio of width to height is 5:8. We can write 5 by 8. This expresses the unique rectangular proportion of the picture. If we look to of other version, the picture Q 2.5 into 4. So we can write 2.5:4. Picture R 10 into 16. So we can write 10:16. Even though the number look different, all these ratios represent the same shape. So how do we prove that these ratios are actually equivalent? When do we this simplifying that? Simplifying the ratio in the simplest form. The ratio is said to be in simplest form when then two terms share the common factor, share no other common factor than 1. Steps to simplify ratio. How we are going to simplify a ratio? Write the ratio in fraction. Find the HCF, means the highest common factor of two numbers, and divide the numerator and denominator by their HCF and convert the fraction back into the ratio form. We will take an example here. Simplify 5:8. The HCF of 5 and 8 is 1. So, it is already in simplest form. Now, you have to practice all the examples. We will take some solved example here. Comparing the ratio in two classes. In class 10, there are 18 boys and 27 girls. And in class Y, there are 14 boys and 21 girls. Are the ratio of boys and girls are same? So, in class X, the ratio is 18:27. We'll change into simplest form 2:3. In class Y, that ratio is 14:21. If we change it to simplest form, that is also 2:3. So, both ratios are equivalent. The classes have the same proportion of boys and girls. Clear? So, you have to practice all the question given here. Now the principle of proportion. The earlier lesson we learned how to simplify the ratio to check whether the two ratios represent the same comparison. This fundamental idea of mathematics is known as proportion. What is proportion? A proportion is the mathematical statement of two ratios describe the same relationship. In the simple word, if two comparisons are equal, they are said to be the proportion. Now, A proportion is written in the form of P ratio Q proportionate to ratio R ratio S. This read as P is to Q as R is to S. That means the ratio P and Q that is equals to ratio R and S. Special name of the terms. In the proportion, the first and last term. The first and last term are called the extremes, and the two middle terms, they are called the means. Understanding these labels help us to verify and solve the proportion easily. Now, how do we check the two ratio form the proportion? There are two common methods. Method 1, simplifying both ratios. If two ratios reduce to same simplest form, then they are proportion. So, here we will take an example. We have to check whether the ratio 18 ratio 24 is proportionate to 27 ratio 36. So, first we will simplify it. So, when we simplify it, divided by SCF, it gives 3 ratio 4 and it also gives 3 ratio 4. So, that we can say that the both ratio are in proportion. Clear? Next is solving an unknown in the proportion. So, how can we find out the unknown quantities in proportion? Proportion are extremely useful because it allows us to determine the missing values when the relationship between the quantities consists. To find the unknown term, the commonly used cross multiplication or the scaling factor method. Both approaches work with the whole numbers, decimals and the fraction. So, method 1, solving using cross multiplication. Rules of 3. Cross multiplication is the most systematic techniques for finding the unknown part of the proportion. So, steps for cross multiplication. Write the two ratios as the equal ratio, placing the missing values in the correct corresponding position. For example, in the comparing student notebook, to keep the order consistent for the proportion P ratio Q proportionate to Q R ratio S. The cross multiplication rule state that solve the resulting equation to find the value of unknown. We will understand it with example. The smoothie recipe use 3 cups of juice to prepare 8 serving. For 8 serving we need 3 cups of juice, and how many cups of juice are needed for 20 serving. So, let us unknown quantity be of juice be x. So, we will write the proportion 8 ratio 3 is proportionate to 20 ratio x. Now, we will cross multiply it. We can write it 8 by 3 equals to 20 upon x. So, that is equals to 8x equals to 3 into 20. When we solve it, we will get 7.5. So, we need 7.5 cups of juice. Historical known. The method of solving proportion with the 3 known values, often called the rule of 3, has been used thousands of years in ancient India. Mathematicians including Aryabhatta use similar techniques in their arithmetic work. Method 2, solving by scaling, the factor of change method. This method is quicker when the number changed by the obvious factor. The idea to determine how much the first ratio was scaled, then apply the same scaling to the other term. So, steps for scaling: identify 2 corresponding numbers term of compute to factor change. Scaling factor new value upon original value. Multiplying the other term in the ratio by the same factor to get the missing value. Example, completing ratio equivalent to 12 ratio 18. We want to fill the missing values in the ratio of proportion 12 ratio 18. So, to find the scaling factor, that is 54 by 18, 3. So, we will multiply the first term, that is 12. 12 into 3, that is 36. So, that is equals to 36 ratio 54. Next is learning point 7.1. So, practice all the questions given in the exercise. Next is real life uses of proportional reasoning. Proportional reasoning help us to understand how two related quantities change together. When one quantity increase or decrease, the other changes in the same ratio. The classical method used in the situation rule for 3, known as the ancient Indian used as Tanasika. which allow us to find the unknown values when three related quantities are known. Let us explore how this concept works through the practical everyday example. Let's take an example here. The carpenter earns rupees 1500 for 5 hours of work. If he works for 8 hours on another job, how much should he pay? So, the solution payment for 5 hours, that is 1500, let the amount for 8 hours is X. Since the more working hours result in more earning, the relationship between hours and payment is proportional. As the hour increase, the payment will increase. So, 5 ratio 1500, that is proportional to 8 ratio X. So, we will find the value of X, that is equals to 2400. Therefore, the carpenter should receive rupees 2400 for 8 hour work. Next is proportional division, sharing of total amount. So far we have learned how to compare quantities using ratio, but sometime we face the opposite situation. We know the total quantity. We need to divide into parts according to the specific ratio. This is where proportional division becomes very useful. Imagine two friends, Maya and Rohan, start a small bakery together. Maya invests rupees 450 and Rohan invests rupees 150. The ratio of their investment is 450 ratio 150, which simplify as 3 ratio 1. When the bakery earned profit, it would not be fair to split it equally because Maya contributed more. Instead of the profit should be shared in the same 3 ratio 1, reflecting each person's contribution. So, proportional division is simply the method of dividing the total amount into parts according to given ratio. Here is the step to divide the total quantity into A ratio B. So, here step 1, add the numbers of ratio to get the total number of equal share, total share A plus B. Now, divide the total quantity of the total number share, find the value of one share. So, value of one share, total quantity divided by A plus B. Now, multiply the value of share by to find the share and by B to find the second share. First share A into value of one share and second share B into value of one share. We will take an example here. Sister Anika and Priya wants to buy a present for their grandmother. The gift cost rupees 360. Anika agrees to pay more, so they decided to split the cost into ratio 3 ratio 2. How much does each sister pay? Solution: total cost of gift is 360. Sum of the ratio 3 plus 2, that is 5. So, value of one person 360 divided by 5, that is 72. So, Anika's share 3 into 72, 216, and Priya's share 2 into 72 rupees, that is 144 rupees. So, Anika pays 216 and Priya will pay 144 rupees. Next is unit conversion. Have you ever tried to compare the length of the pencil to the length of classroom? Suppose the pencil is 18 centimeter long and your classroom is 12 meter long. If you carelessly write this ratio 18 ratio 12, it might misleadingly suggest that the pencil is longer than the classroom. Clearly, this is not correct. The problem is that the units are different. Here you can see one is in centimeter and the other is in meter. So, units are different. To make it meaningful comparison using the ratio and proportion, and what we have to do, the quantities must be expressed in same unit. The golden rule for ratios. When comparing the quantities of the same type like length, time or weight, always convert them to same unit first. First we have to convert them into same unit. For example, comparing minutes to hour directly is like comparing apples to oranges. To make the comparison fair, we must first convert the unit. This process is called the unit conversion, and often the first step is solving the real world ratio problem. Common unit conversion. Here are some frequent use conversion for length. 1 kilometer, that equals to 1000 meter. 1 meter equals to 100 centimeter and 1 centimeter equals to 10 millimeter. For areas 1 hectare equals to 10,000 square meter and 1 acre, that is equals to 4,047 square meter. For volume 1 liter, that is equals to 1000 milliliter and 1 milliliter equals to 1 cubic centimeter. For time, 1 hour equals to 60 minutes, 1 minute equals to 60 seconds. Now we'll take an example here. A baker has 750 gram packets of sugar and 3 kg bags of flour. Find the ratio of the weight of the sugar to weight of flour. So weight are in different unit. First we'll convert them into same unit. So 3 kilogram equals to 3000 gram. Now the unit are same, so we can compare the ratio 750 to 3000. So we'll change into simplest form, that is 1:4. So the ratio of sugar and flour is 1:4. So we'll practice all the example given here. Next is learning point 7.2. Practice all the question given in the exercise. Next is summary. Ratio is the way to compare the quantities written as A:B. We can write it A upon B. Proportion is an equation stating that two ratios are equal. A:B equals to C:D. Extreme and means. In A:B equals to C:D. A and D are extremes and B and C are mean terms. Cross multiplication rule, the proportion A:B equals to C:D. A implies that A into D equals to B into C. Rule of 3 is the method to find unknown quantity in the proportion using the known quantity. Simplifying ratios. So here in simplifying ratios can be simplified by dividing both terms by their greatest common divisor. Proportion division is the process of dividing a total quantity among the parts according to the given ratio. Real life application, ratios and proportion are used in recipes, maps, scales, speed, time, distance problem, sharing money and mixing solution. Unit conversion, often the proportion on reasoning. Example, converting kilometer or hour to minute. Similar the figure, the size of the similar figure in ratios, areas in the square of the ratio of sides. Practical problem solving, understanding the context of the crucial before applying the ratio and proportion. Checking proportion, after solving, verifying the comparing cross product, fractional and decimal. Ratio and proportion can be expressed as a fraction or decimal. Scaling up and down. Proportion reasoning, help in the scaling quantities while keeping relationships constant. Logical thinking. Proportion enhance logical reasoning and decision making in everyday life. So student, here we end the chapter. In this chapter we have learned about the ratio and proportion. How can we solve the problem based on this, their application, all this we have learned in this chapter. I hope this is clear to you. Now to practice it.